Welcome to YOLO Learning Channel, guys. So this is level 1 final stage. It's the boss stage. It's the hardest question of the level 1. And usually those hardest question in level 1 is involving rational functions, the 1 over x, or some people call the reciprocal function too. So let's take a look at this one. Now, when you deal with the rational functions, there are a couple of things that you have to be very careful of. The first thing is the vertical asymptote and the horizontal asymptote, and then the second thing is you have to rearrange it slightly differently from the other functions. Okay, so these two are the things that you have to be very careful of. So let's actually try this. Original function f at x equals 1 over x. The vertical asymptote is where x equals 0, and the horizontal asymptote is where y equals 0. That's because for the vertical asymptote, it's something that your denominator cannot be, and in this case is 0, since 1 over 0 is undefined. And because it is 1 divided by something, and you're dividing one thing by something, it will never be 0. Therefore, the y value, the result of 1 divided by something, will never reach 0. It will only get very closer to it. Now, just to go through the very brief definition of it, the vertical asymptote, it never ever crosses the value. Whereas the horizontal asymptote, which you will actually see in grade 12 as well in the advanced functions, remember that it's a value that a function gets very closer to, okay, as closer to as the x value becomes extreme. So that's something that you have to remember of. Now then, when you figure out the vertical asymptote and the horizontal asymptote of the original, let's actually get to the real question here. So we have g at x equals 2 over 3 minus x plus 1. So we need to rearrange this so that it looks like our regular generic function notation. So if you take a look at this, we have actually 2 over 3 minus x plus 1. Now let's just get rid of the plus 1. Let's just get rid of the 3 minus part. Let's just assume that we have 2 over x. Now, what we had before as the original is 1 over x. Now think of it as, what would you do to this whole 1 over x so that it will become 2 over x? The only thing that you can come up with is then times the whole function by. So when you have 1 over x, the original, when you multiply the whole function by 2, then it becomes 2 over x. So using that, our a value, the value that actually comes at the front, is the 2, since it's going to be 1 over something times 2. So I'll just put the 2 in the front. And then we have 3 minus x. However, it is always easier for us to see that x comes first before any numbers in area per se. So instead of saying 3 minus x, we can actually switch these two so that the order actually is what we like. So I'm going to change this 3 minus x to negative x plus 3. So make sure the sign in front of the x follows. The sign in front of the number follows whatever that you're moving. So the 3 minus x now is then negative x plus 3. And then we have plus 1 at the end. Once you have this, remember that something that is attached to the x must be factored out before we actually figure out what the a, b, c, and d is. So in this case, we have to then factor this negative out, meaning it's negative 1. Then we have 2 times 1 over, then negative is being factored out, and x then minus 3 rather than plus 3 because you're factoring out negative 1, meaning you're dividing everything by negative 1 in this case. So then we have successfully rearranged our function. Now then, using this, what we can find out before we go through the a, b, c, and d is our horizontal and the vertical asymptote. Think of this way, where the vertical asymptote is something that cannot be the x value in the denominator in this case. So remember, x minus 3 cannot be 0 since it's going to be 1 divided by 0 undefined. So then x then cannot be 3. So the vertical asymptote is that x can't be 3. Then for the horizontal asymptote is something that will be either added or subtracted to the 1. Now imagine this, where your denominator becomes extremely large. Let's say 1 over trillion, 1 over gazillion, 1 over Godzilla, 1 over Godzilla, right? Whatever that 1 over thing going to be very closer to 0, and we can assume it is 0, then the horizontal value that the y will approach as the x becomes extremely large will be just 1. But we know that this fraction part will never be 0. It will be very close to 0. Therefore, the y will never be equal to 1, but it will actually just approach. So hopefully here you actually notice it, that this x not equal to 3, which is the vertical asymptote, actually can be found from denominator, whereas the horizontal asymptote here is basically what's after. Okay, so hopefully that makes sense to you. Once you have rearranged them and found the vertical asymptote and the horizontal asymptote, all we can now find is the A, B, C, and D. Now, simple and easy here. Our A is what's at the front. Our B is then obviously -1. Our C is 3. Our D is 1. You should be able to tell what A, B, C, and D is basically by now. Then the mapping method, X is going to be multiplied by a 1 over b value, so it is 1 over -1, and then plus c. Then the y value is then going to be multiplied by the a value and then plus d. Then the rest is just a calculation by plugging the numbers in. Now, depending on who the teacher is, how they teach in class, your reference points for the rational function could be different. So basically you just need to follow those points that your teacher designates to use. In my class, however, I have these 6 points, -2, -1 over 2, -1, -1, -1 over 2, -2, 1 over 2, 2, 1, 1, 2, 1 over 2 are the 6 reference points for the rational function. All you have to do, plug the numbers into the mapping method, and then that's all that is. I've done these calculations already, and all I have to do is 5, 0, 4, -1, 7 over 2, 3, -3, then 5 over 2, 5, 2, 3, 1, 2. Now, just in case you're not so familiar with 7 over 2, that is 3.5, 5 over 2 is then 2.5. Now, then all you have to do is just to plot these on the Cartesian plane, the xy plane, with the horizontal asymptote and the vertical asymptote. Okay, so when you graph these points, it's very straightforward and it's all done. A couple of things that you really have to be careful of is this. I put the green as the transformed graph. As you can see, my transformed points are in green, whereas the blue one is the original or the parent function. Now, some things that you have to be careful of is the axes. You have to actually put the x and y indication and the arrows. The second thing that you have to be careful of is the asymptotes. See, I actually put all the asymptotes here as the equation. These are the line. So you have to put the equations over there, otherwise it is not going to make any sense to some people. And some teachers are very picky like me. I am very picky on these type of things too. So on the test or the quiz, make sure you actually indicate what the equation of the vertical or the horizontal asymptote line is by drawing the dotted line. So hopefully this helped you understand the basic concepts of transformations. And if you like the video, please don't forget to hit the subscribe and like button so that it can motivate me to put more videos. Thanks for watching. I'll see you guys later. Bye bye.